Today we are looking at pressure as a topic, and we begin by asking ourselves, what is pressure? People have talked about pressure, examination pressure, high blood pressure, and many other things. But today we want to know, what does physics say pressure is? Now, for you to understand what pressure is, we are going to look at two main words: force and area. Now, I want to give you a simple example. I know most of us, we must have experienced this. When a doctor injects you using a syringe, even young children whom you think may not be understanding, looking at their age, they understand even better than old people. When it comes to injections, immediately the child looks at a nurse with a syringe. What comes in the mind is injections, and the experience there is pain. Now, when you look at the part of the needle which is used for injection or injecting a person, it is too small. The part which is the area which is supposed to be in contact with the person to be injected is too small. Now, later on we shall find out why should the area be small. But right now, we are talking about pressure. The reason why the child feels a lot of pain is because there is high pressure which is exerted. And as you are all aware that when somebody is being injected, there is a force which is applied at the end of the needle. You see, you apply a force so that the medicine can move. So for us to understand pressure very well, we need to understand those two things: force and area. So we are defining pressure as a force. You see? So pressure is a force. But that force is acting normally per unit area. Pressure is a force acting normally per unit area. Now, what do you mean by a unit? A unit means 1. And the SI unit of area is meters squared. So if you don't want to say per unit area, you could as well say pressure is a force acting per 1 meter squared surface area. Unit means 1, 1 meter squared. 1 meter squared. That means the area is 1. A unit means 1. And the SI unit of area is meter squared. So you could define pressure as a force acting normally per unit area. Or you say it is a force acting normally per 1 meter squared surface area. Now, putting this definition into a mathematical statement, we simply write P is equal to F over A. You see? P, meaning pressure, is equal to force over area. If you want to calculate pressure, you need to know two things: force and area. That's why here we are saying P means pressure, capital F means force, and A means the area of the surface where pressure is being applied or where force is being applied. Now, the SI unit, the unit for pressure has very many units, but the SI unit of pressure is newtons per meters squared. And then the SI unit for force is newtons. While the SI unit of area, we said it is what? Meters squared. You see? So, if my force is in newtons, maybe 30 newtons, and my area is 5 meters squared, you see? When you divide the 30 by 5, you get 6. So my pressure will be 6. But what will be the units? The upper one is in newtons, the downer one is in meters squared. So you write the SI unit of pressure as newtons per meter squared. So whenever you're calculating pressure, make sure the SI unit is newtons per meter squared. Okay, so here we are looking at pressure in solids. Later on, we shall look at pressure in liquids. So as I have just said, if somebody says define pressure and it is 1 mark, before you get that 1 mark, those words must appear. That pressure is a force acting normally per unit area. Or you say pressure is a force acting per 1 meter squared surface area. Now, I have just mentioned the SI unit of pressure, but supposing in part B, somebody says state the SI unit of pressure and it is also 1 mark. You could say the SI unit of pressure is, I mentioned what? Newtons per meter squared, which you can also say newtons per square meter. But there is another name, another word which we have introduced here. That is the pascals, you see? Pascals. So pascals and then the Newton per meter squared are the same. So what does that mean? When you have 1 Newton per meter squared is the same as 1 Pascal. So the SI unit of pressure, you either say Newtons per square meter or you say it is Pascals. And you are also free to write it in abbreviation, PA for Pascals. And then this one is Newtons per meter squared in a short form instead of writing the long form. So it is up to you. You either write in full or you write in short, but you will be still correct. And if the question was 1 mark, you simply get it, whether you have mentioned Pascals or Newtons per meter squared. Now let's go to another interesting question here. State and explain the factors on which pressure in solids depends. What are the factors? Pressure in solids depends on what? What are the factors which determine, which affect pressure in solids? Now that one takes us to the formula. The factors which affect pressure in solids are force and area. How big is the force and how big is the area? Now very soon we are going to see. Now this question says state and explain. So if the question was saying state, you would just say force as 1 point, then surface area as the second point. But there is another word here. After stating, explain. What does that mean? After you have said that the force affects pressure, how does it affect? So you must explain. When I increase the force, what happens to pressure? Does it increase or it reduces? Then after mentioning, stating area, surface area as another factor, you are supposed to explain how does the area affect what? Pressure. Now I have just given a simple example that when somebody is going to be injected with a needle, the part of the needle which is supposed to be in contact with the body is always made very small. Why? Now I want us to look at this formula properly. This P and F, they are up. They are like on the numerator, while the area is down. And we all know that the opposite of up is down. So what does that mean? It means when the force is big, the pressure is also big. You see? When you apply force, like when the doctor is injecting and then he pushes, he pushes the piston or the plunger using a high force, you will hear the child crying more. Why? Because the pressure is high. So when the force is high, the pressure is also high. What about the area? The area is down. The pressure is up. What does that mean? When the area is small, the pressure is big. You see, the reason why they have used the small part of the needle to be in contact with the body, it means the surface area is small. And when the surface area is small, the pressure becomes high. So let us put that in writing. State the factors. The factors are force. Force is the same as the weight of the body. Then the another factor is area of contact. So if this person had said state without explaining, you would just mention this force and then area of contact and you are through. But since he wants you to explain or she wants you to explain, after stating, state and explain. This is why sometimes the students fail exams. Somebody says state and explain. Then for you just state. You say force and then area. You have stated. You will get the marks for stating. But you will not get marks for explaining. After stating force as a factor which affects what? Pressure. Can you go ahead and explain? So we have just said that the greater the force, what happens? The greater the pressure. When the force is big, the pressure is also big. You see? Then the other factor is the area of contact. You see? The area, that part of the needle which touches the body is always made very small. Why? And we are saying the bigger the surface area, the smaller the pressure. You see? When you make that area to be big, it means the pressure is going to be very small. So for that reason, what do? We make it small so that the pressure is big. So how does the area of contact affect pressure? The area of contact affects pressure in a way that when the area of contact is small, the pressure is big. And when the area of contact is big, then the pressure is small. You see? This is what the examiner wants. And here we have 4 marks. You see? So the first factor was force. You get 1 mark. Then here mentioning that when the force is big, the pressure is big. You also get 1 mark, a half. The greater the force, when the force is great, yes, what happens? The pressure is also great. You get your marks. Then here mentioning the area of contact, you have stated. Then you come and explain. When the area of contact is big, the pressure becomes small. And you get all your marks. Now, we can get the relationship. Let's go ahead. Let's look at the relationship between pressure and area. You see? Let us understand this thing better. The relationship between pressure and area. We want to see what happens. We want to understand the relationship between pressure and area. You see? The relationship between pressure and area. Consider a block of weight 60 newtons as shown in the diagram below. And after considering, you are supposed to calculate the minimum, which is the same as the smallest pressure. Then you also calculate the greatest or the maximum pressure. Now, we are told you have a block. I want to use this book as an example. You see? Supposing this book is representing this block. This is, you see? Supposing this book is representing, or I could still use another one. Let me use my phone here, small phone. You see? Supposing this side is 6, this is 6 meters. And then this side is what? 4 meters. You know, this phone has the length, which is this, the width, which is this, and the height, which is this one. You see, the height. Now, supposing the length is 6 meters, the width is 4 meters, and the height is what? 2 meters. When you put this phone like this, what happens? The length is 6, the width is what? 2, is 4, and the height is 2. What about when I turn it like this? What happens? The height, the length, the width changes. What about when I put it like this? It still changes, you see? So this is what we are trying to explain. So each time you change this phone, the area changes. The length, and how do you get the area of a rectangle? Length times the width. So we are saying, supposing you consider a block which has a weight of 60 newtons. You know, the block has a weight of 60 newtons. So this block, these 3 diagrams, they mean the same thing. This block is the same as this one, is the same as this one. Why? Because the dimensions are the same. When I talk about dimensions, I'm meaning the length, the width, and the height. You know, 6, 4, you see, when you look at this diagram, there is a 6 here, there is a 4, there is a 2. When you look at here, there's also 6, there is a 2, there is a 4. When you look at here, there is 6, there is a 4, there is a 2. You see? So it is the same block. But now, as you keep changing the sides, there is a time when the length is 2, the width is 4. No, the length is 4, the width is 2, and the height is 6. When you change it again, there is a time when the length is 6, the width is 2, and the height is 4. Then again, when you change, time comes for the length to be what? 4 or 6, the width is 4, and what? The height is 2. So you see, it is like I said about this phone. When you put this phone like this, the length and the width is not the same as when you put like this. When you put like this, the length and width changes. When you turn like this, the length and width what? Changes. So it is the same block, as I have used an example, the same phone. Now, let us calculate. We want the minimum pressure and we want the maximum pressure. You see, calculate the minimum pressure, which is the smallest. And then we are supposed to calculate the greatest what? Pressure. So what we are going to do, we are going to calculate the area. When this block is like this, what is the area? When it is like this, what is the area? And when it is like this, what is the area? So we begin. Let's begin with this part. So we have 3 parts now. And because we have 3 parts, I have decided to call it part 1, part 2, and part 3. Let's look at part 1. In part 1, area is the same as length times width. Our length here is 4, the width is 2. You know, this one is now the height. This is now the height. So, what happens? Now, what happens here? So, what happens here? I've just said that we are going to have 3 parts. In part 1, the area is going to be 4 length times width, which is 2. And the answer will be 8 meters squared. We all know that the area of a rectangle is, area is equal to length times width. 4 times 2, you get what? 8. The units will also multiply. Meter times a meter, you get 8 meters squared. You see? Then when we come here, our area changes as we change the block. The area is the same as length times width. The formula remains the same. But here the length is now 6 meters and the width is 2. So when you multiply 6 meters times 2 meters, you get 12 meters squared. When you turn the block again, you see, this time the area will be 6 times 4, the length times width. You see, our area still remains length times width. This time is 6 times 4, you get 24 meters squared. So what does that mean? Each time you turn the block, the area changes. Now that we have very many areas, we have 3 areas. In part 1, when you change, in part 2 and part 3. Let's calculate the pressure for all of them. In part 1, the formula for pressure remains the same, force over area. We shall have pressure being equals force over area. Our force was 60 newtons. They told us that this block has a weight of 60 newtons. The force is the same as the weight. So our force is 60 newtons, but our area in part 1 is 8 meters squared. So when we divide this 60 newtons as a force divided by 8 meters squared, the calculator will give us 7.5 as the answer for pressure. So therefore our pressure here is going to be 7.5. I said the SI unit of pressure is either pascals or newtons per meter squared. So after getting the answer, you put the units for pressure, newtons per meter squared. Then when you go to part 2, where we got our area as 12 meters squared, we shall also calculate the pressure here. Pressure is equal to force over area. The force is 60 newtons, but our area in this case was 12 meters squared. So when we divide, we substitute, our pressure is going to be 5. After getting 5, you write the units for pressure. You either write pascals or you write what? Newtons per meter squared. You choose one. Okay, then we go to part 3. The area is still length times width. Here the length is 6, the longer side is 6. Length comes from the word long, the longer side. Then the width is 4. So when you multiply, what do you get? What do you get? When you 6 times 4, you get 24 meters squared. So our pressure is going to be force divided by area. The force remains 60. Remember, this is the same block. So it is 60 newtons divided by 12 meters squared. And your answer becomes 2.5 pascals. You either use the pascals or newtons per meter squared. Now, after getting all the 3 pressures, we now compare. Remember, the question wants us what? Which one is the smallest pressure? And which one is the greatest pressure? The smallest pressure is also called minimum pressure. So when we compare all this, the smallest pressure, because here the first case we had 7.5, then we have 5, and then we have 2.5. Automatically the smallest is 2.5 pascals. Then the highest, which is the greatest, the maximum pressure is what? 7.5 newtons per meter squared. So we have already got the answers. So how many marks were given here? 4 marks. How do we give those marks? You see, the answer, a half. The unit, a half. That's 1 mark. Substitution for pressure, a half. The formula for pressure, a half. That's another 1 mark. Those are 2 marks. Then you have calculating the area. Formula for the area, a half. Substituting for length times width, a half. The correct answer and the correct unit. So this is what happens in part 1, in part 2, and part 3. But now part 2, we are not awarding marks. Why are we not awarding marks for part 2? Because the question is, they want minimum pressure and maximum pressure. There are only 2 pressures which they want, not 3. So the highest is 7.5. That's why we are awarding for the maximum, and then for minimum is 2.5. Now, next time, when somebody tells you to calculate the minimum pressure and the maximum pressure, what do you do? Because when you look at it here, the force is the same. 60 newtons, 60 newtons, 60 newtons. So what has changed here? It is the area. You see? 24 meters squared, 12 meters squared, and 8 meters squared. So when you compare the areas, which one was the greatest area? The greatest area is 24. And that is where we got the smallest pressure. So what does that mean? When somebody tells you to calculate the smallest pressure, you use the greatest area. Now let's look at here, where we got the greatest pressure. When somebody tells you to calculate the greatest pressure, you use the smallest area. So what does that mean? Pressure, when the pressure is big, you see, 7.5 is the biggest pressure. The area is the smallest. You see, 8 meters squared was the first area, which is the smallest. You see, the smallest is 8, because this is 8, this is 12, and this is 24. So the smallest area is what? 8. And that is where we go to the maximum pressure. So when somebody tells you to calculate the greatest pressure, use the smallest area. And when somebody tells you to calculate the smallest pressure, use the highest area or the greatest area. So what does that mean? This now concludes to us that when the pressure is small, the area is big. And when the area is big, the pressure is small. Now, this one now takes us to another level where I am now going to introduce you to the conclusion. You see, we are now going to conclude about what we have just learned. You see, we're going to conclude on what we have just learned. Let us conclude. Our first conclusion says pressure is inversely proportional to surface area. What does that mean? Inversely proportional here means when the pressure is big, the surface area is small. And when the surface area is small, when the pressure is big, the surface area is small. And when the pressure is small, the surface area is big. So the smaller the area, the greater the pressure. And the bigger the area, the smaller the pressure. So if you have two people, one looks bigger than the other, automatically when it comes to pressure, the person who is big has a bigger area, and therefore the pressure is small. And the person who is small has a smaller area, and therefore the pressure is big. Another conclusion we can draw from that is that the greatest pressure, the maximum pressure, you get it from the smallest area. And the smallest pressure, you get it from the biggest area. Now, let us look at this quick example. Some examples here. Number 1, a block of concrete weighs 900 newtons. And its base area is a square of side 2 meters. So in this question, what is the question? They are saying, what pressure does it exert on the floor? So they have told us that a concrete block, concrete is always used for building. So a concrete block weighs what? 900 newtons. Anything in newtons is what? Force. So as part of our solution, we shall say the force is already given as 900 newtons. Now, we are told, and the base area, the area of that concrete is a square. So the concrete block does not look like a rectangle, does not look like a triangle, but it looks like a square. And we all know that a square has sides which are equal. So they have told us that the base area is a square. So the concrete block looks like what? A square. And each side is 2 meters. So we shall say our area, since the thing looks like a square, the concrete block looks like a square. How do you get the area of a square? Area of a square, you calculate it by, you get it from side times side. So since the sides are equal, we shall have 2 meters as one side times another 2 meters. Because they are the same. And you get 4 meters squared as the area. Now that you know the force, and you have calculated the area, you can now get your pressure by saying pressure equals force over area. Where there is a force, you substitute 900 newtons. Where there is area, which you have just calculated here, you put 4 meters squared. And when you divide the two, your pressure becomes 225. Don't forget to write the units for pressure as either pascals or newtons per meters squared. Now, in this question, we had 4 marks. Calculating the area of a square, the formula, the substitution, the correct answer, and the units. Each one a half. So that one gives us a total of 2 marks. Then calculating pressure now. Formula for pressure, substitution, the correct answer, and unit. Each one is also a half. Those are 2 marks. 2 plus 2, you get all your 4 marks. Let's look at another example. This one says a rectangular block. So this time the block looks like a rectangle. A rectangular block measures 2 meters by 3 meters by 4 meters. So there is a length there, there is a width there, and there is a height there. 2 meters by 3 meters by 4 meters. And it's saying if it is a mass, if the mass of that block is 24 kilograms, calculate the part A, the weight of the block, B, the maximum pressure, and then C, the minimum pressure. So what do? We begin with the weight. Since we know the mass is 24 kilograms. You see the mass is here. Since we know the mass, by the way, the SI unit of mass is kilograms. So our mass is already kilograms. Now we want the weight. The relationship between mass and weight is in the form of an equation which says weight is equal to mass times acceleration due to gravity. Now, the value of acceleration due to gravity is always given, and you are supposed to use the one they have given you. Now, in this case, we have not been given. When you are not given, then you use 10. You see? But sometimes they can give you 10, they can give you 9.81, they can give you 9.8. Please, when you are substituting, write here what the examiner has given you. Don't write 10 when they have given you 9.81. But if you are not given, you can use 10. And mass times acceleration due to gravity. Our mass was 24 kilograms, already in SI unit. And acceleration due to gravity is 10. When you multiply, your weight is 240 newtons. And that one is the answer for the first part. Let's go for maximum and minimum pressure. What did we say? That when you are calculating the maximum pressure, which area do you use? You use the smallest area. And when you are calculating the minimum pressure, you use the greatest area. So, we shall say maximum pressure is equal to force divided by smallest area. And then when it comes to minimum pressure, we shall say minimum pressure is equal to force divided by the greatest area. So let's first calculate the areas. When you keep changing this rectangular block, the first area is 2 length times width, 2 times 3, that will be 6 meters squared. Another area will be 2 times 4, which is 8 meters squared. Another side will be 3 times 4, which is what? 12 meters squared. So which one is the greatest? 12 meters squared. So if the greatest area is 12 meters squared, we use that area for calculating the smallest pressure. You see, the minimum pressure is equal to force divided by the greatest what? Area. And our greatest area is what? 12. That is 4 times 3. So when you divide these two, you get 20. That becomes the minimum pressure. Then for the maximum pressure, you use the smallest area. What is the smallest area? The smallest area, let's go back here. What is the smallest area? The smallest area will be 2 times 3, which will be 6. You see? So we shall divide the force, which we got as 240 here. The force is the same as the weight. And then we divide by the smallest what? Area, which is 6. And our answer becomes 40. And after writing 40, the SI unit of pressure is supposed to be pascals. You either use the pascals or use newtons per meters squared.